Hi everyone, I am Arvind Sharma from team SleepWalkers. I am here to present my idea for Smart India Hackathon 2024. So our problem statement is develop a functional solution that incorporates the security of the ML model for UIDAI face authentication system. To ensure the end-to-end security of our solution, we have broken down into 4 modules. First module is model obfuscation. Model obfuscation is renaming the model nodes, parameters and attributes so that it is very hard for anyone to reverse engineer it. In this we'll be using neural architecture search to find functionally equivalent but structurally different architectures. We'll mix and match these architectures so that it is very hard to reverse engineer them. The second module will be model encryption. In this, the model binary will be encrypted using AES-256 in an authenticated mode on the backend, that is server side. The encryption key will also be generated on the backend. Whenever the client wants to use our model, the client will generate an RSA key pair to retrieve the AES key from the server. But now everyone will have a question that you have the AES key, you have the encrypted model, anyone can hack into the client and retrieve all the information. But no, this will all happen in a secure environment execution, which is we'll use a WebAssembly module, which is a low level assembly like language, which is a secure and isolated from the JavaScript runtime. After that, the fourth module is when we have to update the model and revoke it from a client. So whenever the model needs to be updated, a new version will be obfuscated, encrypted and sent over to the client. Now this model will be further used by the client for further inferencing. Now let's understand the technical approach using these two diagrams. So first one is whenever the client wants to initiate for the first time face authentication, it will request to download the model from the server. The server will encrypt the model using AES and sends the encrypted model over to the client. Now in this second diagram we can see that the client has the encrypted model in its cache, but whenever client wants to use it, it will request face authentication and it will generate public and private RSA key pair. It will send this public key over to the server to retrieve the AES key. On the server side, server will use this public key to encrypt the AES key using client's public key. Then this AES key which is encrypted and is like this will be sent back to the client. To better understand it, we have made a sequence diagram to know the sequence of requests. So for the first time, when the client requests Onyx model from the server will authenticate the client and generate and store the AES key into a key management system. After that, the server will encrypt and obfuscate Onyx model using AES key and sends it back to the client. The client will store this encrypted Onyx model into a browser cache. After that, whenever client wants to inference the model, it will generate RSA key pair in WebAssembly module, and after that public and private key will be generated. The client will send the public RSA key via HTTPS to the server. The server will authenticate the client first, then retrieve the AES key from the KMS, which is key management system, and encrypt AES key with public RSA key onto the server only. After that, the server will send this encrypted AES key back to the client. Now the client will retrieve a copy of encrypted Onyx model from the browser cache and load copy of encrypted model along with this encrypted AES key over to the WebAssembly. Now all of the operations will be held on the WebAssembly, which is decrypting of the AES key, decrypting of the Onyx model using AES key, and running the Onyx model inference onto the WebAssembly module. As Onyx runtime supports WebAssembly module, we can do this step. After that, the results will be sent back to the client and everything, the decrypted data and keys, WebAssembly memory will be erased. For further inferencing, the client has to repeat steps from here, which are generating RSA key pair, retrieving the AES key from the server, and then everything should be loaded on the WebAssembly where further operations will happen. So this was the technical approach of our whole solution. For the rest of the things, innovation and everything, you can refer to our presentation, which will be linked in our description. Thank you.